Here we are on Chapter 5, Lesson 3, page 204, Distributing Heat. Say that, distributing heat. The main idea is thermal energy can be transferred by conduction, convection, or radiation. Okay, we have already learned a little bit about radiation through electromagnetism and light from the sun as energy. Now we're going to learn more about conduction and convection. Okay, first thing's the same. Write your name. AVID 6. January 25th, 2021 is today's date. We are doing Science FNT is our topic/objective. Chapter 5, Lesson 3, page 204. And the title of this lesson is Distributing Heat. Our main idea/essential question, thermal energy transfer via conduction, convection, radiation. Okay, so we used some of those words to put over here. Write all of your vocabulary words. Conduction is on page 205. Conduction is the transfer of thermal energy by particle collision. The collisions transfer energy, but not matter. So, transfer thermal energy by particle collision. Those words are in here, by particle collision. Next up, convection. Convection is the transfer of thermal energy by mass movement of particles in a liquid or gas. Convection, I put ... because it's the transfer, by mass movement, liquid/gas. So liquids can swirl and move, gases can mix when the air blows. That's convection by mass movement, and it happens in liquids and gases. Convection current. Hopefully this is ringing a bell. You've heard this before when we talked about the mantle and the core of the Earth. We talked about magma and the convection currents underneath the tectonic plates. Convection current. This continuous loop of moving water is called a convection current. So convection current is a continuous moving loop, and that reminds us of the mantle and magma. So that's why we put it there. Oh, hey, I remember what that was. Next up, density. Page 205. Density is the amount of mass per unit volume of a substance. Density, mass per unit volume. Okay, now, what does that really mean? The warmer, less dense water rises. Okay. So, low equals float. If something has low density, then it generally wants to float. An example would be foam or a boat. I put wood in the middle. Sometimes wood can float on water. Other times wood sinks in water. Okay? Over here for high equals sink, high density materials tend to sink to the bottom. That would be like a metal bar, right? If you had a big old chunk of metal or a bar of metal, it would sink to the bottom. You could even put rocks over here. Rocks sink. Okay, next up is heat. Page 204. Transferred energy is called heat. Okay, what else is it? When a hot object is in contact with a cold object, thermal energy is always transferred from the hot object to the cold object. So heat is thermal energy. Okay, and we're going to learn something later on about atoms vibrating. V-I-B-R-A-T-I-N-G. Quotes around that. So remember when they talked about particle collision with conduction? The particles, or the atoms and molecules, are colliding or bouncing on each other and hitting each other. Okay? It's transferring energy because they're hitting each other next to each other, but they're not transferring matter. In other words, the particles are not flowing like a liquid, like a water, or flowing like air and mixing. They are vibrating and bouncing and colliding against each other. So heat is thermal energy when the atoms are vibrating or colliding, resulting in particle collision. Okay, land breeze, page 207. Land breeze. The result is a cool wind blowing near the surface from land towards sea, called a land breeze. So land breeze, here's the land. Cool air is blowing out to the sea where it's warm. Here's a picture of land breeze. Okay, we're going to learn later on that what's really happening is the warm air is less dense, so it's rising or floating. As it's rising, it cools and wants to come back down. All of that action is sucking the air from here over land out to the ocean and creating this continuous loop. So, air is blowing from land, and the cool air is blowing out over the sea where the warmth is. Okay, the next one up after that is sea breeze. Cool air that blows along the surface from the water toward land is called a sea breeze. So, from the sea, the cool air is blowing back toward the land where it's warm. Okay, here's an example of that. When it's warm over the land, it rises because it's less dense. As it starts to mix, it will cool down. As that's all rising, it's sucking this cool air from the sea back in towards the land and creating this continuous loop. Next word, temperature. 204, temperature. Here, the average motion energy of the particles is the temperature. Okay? Temperature, average motion energy of particles. Thermal energy, right there. In any sample of matter, the total amount of motion energy from its moving particles is called the sample's thermal energy. Thermal energy is total motion energy of particles. So temperature is the average, like from one particle to the next. Thermal energy is the total energy of the whole thing. Okay, good example would be like in this fish tank. The temperature is warmer at the top and cold or less at the bottom. But the thermal energy of this entire tank stays the same. Okay, now, first section is called conduction and convection. Conduction and convection. Have you ever heated food on a stove, warmed your hands by a fire, or watched ice melt? If so, you observed changes that involved a transfer of thermal energy. But just what is thermal energy? All matter is made of tiny particles that are in constant random motion. Okay, so we already had heating equals transfer of thermal energy. Where was that? Heating is transfer of thermal energy. Okay, next up, it said that particles are in constant random motion. Particles / atoms in motion. Zoop. We put a little arrow pointing to the energy because that motion is very much like energy. In any sample of matter, the total amount of motion energy from its moving particles is called the sample's thermal energy. The average motion energy of the particle is the temperature. We already have those two words, so we don't need to write anything new. Temperature describes how hot or cold something is. When a hot object is in contact with a cold object, thermal energy is always transferred from the hot object to the cold object. Okay? Hot, exclamation point, arrow towards the cold, energy transfer. Energy transfers from hot things to cold things. Okay? This transferred energy is called heat. So, in quotes, heat. The transfer of energy continues until both objects have the same temperature. Okay, thermal energy is transferred by one of three processes: radiation, conduction, and convection. Oh, they're listing three things. Let me guess. I'm going to have three things on my paper. Radiation is the transfer of thermal energy by way of electromagnetic waves. Recall that the sun gives off energy by emitting radiation. So, going back to the last lesson, previous lesson, radiation equals electromagnetic. And we go from radio waves, low energy, towards infrared, warmth, light that we can see, and beyond to ultraviolet, which we cannot see, but can give us sunburns and has a lot of energy. That's why I went from the bottom of the line towards the top of the line as we went radio, IR, light, UV. Each of these has successively more energy. Conduction is the transfer of thermal energy by particle collision. The collisions transfer energy, but not matter. Okay? Conduction equals energy, zoop, not matter. In other words, they're bouncing and hitting each other and vibrating and transferring energy, but they don't flow like water moving, and they don't flow like air mixing. It would not be the flow like this. It's more like the hot at this end of the bar eventually works its way down toward the cool end of the bar. Okay. In the metal rod, pictured on page 204. There it is. Particles in the hot end have higher energy and vibrate more strongly. They collide with nearby particles, transferring some of their motion energy. As a result, energy will be transferred from the hot end across the rod toward the cooler end. So from the hot across toward the cool. Hot end, arrow, metal bar, arrow, cool end. Heat or thermal energy is transferring from the hot end through the metal bar toward the cool end. Okay, another example of conduction where something hot is touching something cool. Hot food on tongue. T-O-N-G-U-E. When you touch hot food to your tongue, the hot food is the hot, your tongue is the cool, and that is conduction energy. Right? The food is not flowing into your tongue, but you are still getting energy. So energy, but not matter. Convection. In air, water, and other fluids, thermal energy is transferred mostly by a process called convection. That's convection. Remember convection from the magma in plate tectonics? The swirling magma underneath the plates? Convection is the transfer of thermal energy by mass movement of particles in a liquid or gas. Convection transports matter as well as energy. Okay? So, convection equals air, zoop, water, zoop, fluids. To understand convection, look at the aquarium above. It uses a heater to warm the water that comes in contact with it. As it warms, the water expands, causing its density to decrease. It becomes lighter. It wants to float. Density is the amount of mass per unit volume of a substance. The warmer, less dense water rises, or floats. When the rising warm water reaches the surface, it cools. Its thermal energy is transferred to surrounding water particles by collision. The water becomes denser and sinks. Okay, so it starts to cool down. It becomes more dense. Its density increases, so it starts to sink towards the bottom. Eventually, the water reaches the heater, is warmed anew, which means warmed again, and begins another journey through the aquarium. So the hot water rises, the cool water descends, and eventually makes it back to the heater and starts that whole cycle again. This continuous loop of moving water is called a convection current. Okay, so let's draw a picture. In the bottom left, step number 1 is warm. The 3 little arrows kind of go up and to the right because the warm water wants to rise. Above those, we write less dense. That's step number 2. The warm water becomes less dense and wants to rise or float or move up. Then we draw some arrows coming around in a circular motion. And step 3 is cool. As the water or the air or the fluid cools down, it starts creating this circular motion, and it will come back to step 1 where it warms up. Okay? Mass/matter moves. Mass is particles, stuff that you can hold or see or feel. Same thing for matter. So remember, in conduction, the metal's not moving, but the heat is moving down the bar. In convection, the water is actually moving and swirling in that convection current. All right, let's ask our main idea. How is thermal energy transferred? Okay, let's answer it. Thermal energy is transferred in one of three ways. Radiation, so I put a letter A next to it. Conduction, B, or C, convection. And then we would add details. Radiation is electromagnetic energy, for example, radio waves, infrared, light, or UV. It can move through empty space. Conduction is when energy transfers but matter does not move. For example, the hot end of a metal bar transfers energy toward the cool end, or hot food on our tongue feels hot. Convection is when a fluid moves, like air or water. Warm fluid, warm air, warm water becomes less dense and rises. Eventually, it will cool down and fall or sink and start this whole convection current. Currents of water or air created by the process of convection are called convection currents. Okay? That looks exactly like the swirls underneath the tectonic plates from previous lessons. Thermal energy is transferred from the red-hot end of the rod to the cooler black end by conduction. Okay, so here's an example of conduction. Here's an example of convection. Two different processes. Energy transferring, but the particles are not moving with it. Here you have mass movement or matter movement. The water is literally moving and swirling in the tank. Or the air is blowing in the classroom from fans. All right, that's it for day one. Good job persevering with the growth mindset. Roar, Wildcats.